All right, so we have e to the 7x minus 5, then minus 2 equals to 27,531. We want to isolate our exponential term, meaning I want this e to the 7 raised to the 7x minus 5 to be by itself. So we're going to add 2 to both sides. So we have here e to the 7x minus 5 equals 227,533. Okay, so next, because we have a base e, we're going to take the natural log to both sides. Here again, meaning we're going to write ln to both sides. So we have ln of e to the 7x minus 5 equals to ln of 27533. Now, this ln of e raised to the 7x minus 5, we still can use this property where we can drop the ln of e because it's going to equal to that power. So we have here 7x minus 5 is equal to ln of 27,533, and we want to solve for x. So we're going to add 5 to each side. Now keep in mind 5 and the natural log, those are not the same. They are different. One is the natural log, one is a constant term. So we have 7x is equal to ln of 27,533 plus 5 all over. And when I say all over, what's going to happen? We're going to have to divide by 7 to both sides. Okay. And then we have here x is equal to ln of 27,533 plus 5 all over 7. So this is our natural log. This is our solution. Now you may say, well, Mrs. Lewis, how would you put this information in the calculator? So we're going to do it in parts. So pay attention to this, okay? So, all right, so if you notice the cursor is moving around the calculator. So let's do this in parts and try instead of trying to do everything in the calculator. So before we do that, we've expressed this as a natural log. Now I need you to find the approximation to that. So let's do ln of 27533, and let's close it with parentheses, and let's press enter. Okay. Then put plus 5 and then press enter. Then let's divide all of that by 7. And let's press enter. And what do we have once we round? Here is part A. Okay. Part B, when we round, we have here 2.17 as our solution when we round. Okay. Last example for this one, this particular concept, we have here, and let me clear the calculator. We have ln of x is equal to 10. Okay, so we're saying normally when we have a base e, we take the natural log to both sides. Well, this time, since it's already written with the natural log, we're going to take the e and we're going to raise both sides with a base e. Okay, So we have here E ln of x. That's going to give us x is equal to e raised to the 10th power. So you do have a property that says whenever you have a base e raised to its natural log of x is going to be that x. Okay, so we've expressed this with base e. Now let's go ahead and write the approximation. So let's find e. So to find e, you have to use your second key and look at ln. Above that, you have e to the x. So we have second and ln, which is e. And then we're going to put in what the power is, 10, and press enter. And let's raise this to 2 places. So this would be 22026.4 what? What is that last digit? 7, because you have a 6 there, and right, the 6 is the number that we're going to be looking at. I'm going to use my cursor here. The 6 is what we're going to determine if it's going to stay or we add 1. Well, we look to the right, we have a 5, greater than 5 or greater, we add 1 to the 6, so that becomes a 7. And so our decimal approximation is 22,026.47.